Hello everyone, welcome to the last portion of our lesson on 8.5, and today we are going to be graphing secant and cosecant functions. Secant and cosecant are the reciprocal of cosine and sine respectively. We're going to compare the graphs of cosine to secant and sine to cosecant. So the graphs of secant and cosecant are these kind of funky looking graphs where you have like these horseshoes or like these mini parabolas in between vertical asymptotes. The domain of the secant parent function is going to be all real numbers except odd multiples of pi over 2, and that's because at those odd multiples of pi over 2, the value of the cosine function is going to be 0, and if you take the reciprocal of 0 to get the secant function, that becomes undefined. So that is why we have those vertical asymptotes at any x value that makes the function equal to 0, and for the parent function that occurs at odd multiples of pi over 2. Cosecant looks very similar, and it also has like the horseshoe shapes in between the vertical asymptotes, and it alternates, one increasing, one decreasing. And the domain is also going to be all real numbers except for multiples of pi. And same thing here, because at multiples of pi, your sine value is going to be equal to 0. If you take the reciprocal of that to get the cosecant values, this number will be undefined. The range of the functions for both cosecant and secant, it's going to be a y is greater than or equal to the maximum of your cosine or sine function, and y is less than or equal to the minimum of your cosine or sine function. And the period of both graphs is going to be 2 pi. If you wanted to graph y is equal to a secant of bx or y a cosecant of bx, you're going to first graph the reciprocal function, so either the cosine or sine function. And then you're going to draw vertical asymptotes at the x-intercepts of your function. And after you graph those vertical asymptotes, you are going to make points at the minimum or maximum of the functions. And then just draw a parabola or U shape. You want it to go up if it's at a maximum, and you want it to go down if it's at a minimum. So with that in mind, we are going to start graphing secant and cosecant. In example 3, we are going to be graphing the secant function, and we are going to graph one period of the function g of x is equal to 2 secant of x. After we graph it, we're going to describe the transformation on the parent function f of x is equal to secant of x. Our first step is to graph the cosine function. So we want to graph 2 cosine of x. And once we graph the graph of cosine, then we can graph our secant graph. We want to first find the period, and because the coefficient of your x value is 1, the period is going to be 2 pi. So we're going to place 2 pi on our x-axis. We always divide it into fourths. And now let's graph our cosine function. Because our a value is 2, and there is no vertical transformation, the midline is going to be at the x-axis, and we are going to have a maximum of 2 and a minimum of -2. The graph of cosine has a x-intercept at your maximum 2. It's going to go down to the x-axis, down to your minimum, back up to the x-axis, and up to the maximum. There is our graph of 2 cosine of x, but we want the graph of the secant function. So first we are going to draw vertical asymptotes at the x-intercepts of your cosine graph. So we have an x-intercept here at -3 pi over 2, another x-intercept at -pi over 2, an x-intercept at pi over 2. We only need to graph one period of this function, so you just need a graph within 2 sections of vertical asymptotes, and you want to select the minimum and maximum points. So we have one here at 0, 2, and then we're going to draw a horseshoe shape up. And we have a minimum here at pi, -2. Make a point there, and then we're going to draw that horseshoe shape down. And that's our graph of the secant function. We could draw another one right here too. Again, we have another point at -pi, -2. It's going to go down because this is the minimum part of the graph. Now let's just describe the transformation. Vertical stretch by 2. Let's graph secant one more time. For monitoring progress 8, we're going to do the same thing. We're going to graph g of x is equal to 2 secant pi of x. So we want to graph 2 cosine pi of x. We want to start off by finding the period. We have a period of 2. Place 2 on your graph and divide into fourths. And then we're going to graph 2 cosine pi of x. Cosine has a y-intercept at the maximum, which is 2. Goes down to the midline, down to the minimum, back up to the midline, Now let's draw vertical asymptotes at the x-intercepts of our function. Now once you have those vertical asymptotes, let's graph our function. So points that are on this function are the minimum and maximum points of your cosine function. So we know we have a point right here at 0, 2, at 1, -2, and at -1, -2. And then once you have those points established, you're just going to draw a horseshoe shape going towards the vertical asymptotes. There's the graph of your function, and now let's just describe the transformations. We have a vertical stretch by 2 and a horizontal shrink by 1/pi. Let's move on to graphing cosecant, which is going to be very similar to this procedure. In example 4, we are asked to graph g of x is equal to 1/2 cosecant pi of x. We'll first start off by graphing half sine pi of x. Now let's graph the sine function. It starts at the origin, and then it's going to go up to the maximum at 1/2, down to the x-axis, down to the minimum, and then back up to the x-axis. You want to draw vertical asymptotes at the x-intercepts. Then you want to identify some points that are on the function. So these occur at like the minimum and maximums of your function. And then you're going to draw the horseshoe parabola-like shapes. There's our function, and let's just describe the transformation. We have a vertical shrink by 1/2 and a horizontal shrink by 1/pi. Let's see this one more time. For monitoring progress, we're going to graph 2 cosecant of 2x. First going to graph y is equal to 2 sine of 2x. And now let's graph the function. Now let's draw the vertical asymptotes at the x-intercepts, and then identify some points that are on your cosecant function. So these occur at the minimum and maximums of the function, and then just draw those horseshoe-like shapes. And lastly, let's describe the transformations. We have a vertical shrink by 2 and a horizontal shrink by 1/2. That's it for our lesson for today. Please let me know if you have any questions, and come to office hours if you need help. I hope you have a wonderful day, and take care.